Let's start the section by considering two graphs. The first graph represents a curve which gives the slope of the tangent and it has to do with differentiation. Now, if we consider the second graph, what does it represent? The second graph represents the area under the curve. And the area under the curve involves much of the integration. These two graphs represents two different concepts. Differentiation and integration. Trying to put these two ideas together, which can be done through fundamental theorem of calculus. So, the fundamental theorem of calculus is a theorem that links the concept of differentiating a function with the concept of integrating a function. Now, if you see in the second graph, x is a point in the interval a to b. Then, integral a to x, f of x dx is nothing but area of the shaded region. Here, area of the shaded region depends on the value of x. So, we can write integral a to x f of x dx is equal to a1 of x. Now, if I shift this value of x towards the right of the curve or towards the left of the curve, then this integral value, that is integral a to x f of x dx, will give another value. If that value is a to x, then we can understand that the area of the region depends on nothing but the x value. So, in general, the area function is given by a of x is equal to integral a to x f of x dx. Now, let's state the first fundamental theorem of calculus. Let f be a continuous function on the interval a to b, then a dash of x is equal to f of x for all x element of a, b. And this is the interval where what is a of x? A of x is the area function, which is nothing but integral a to x f of x ds. Now, let's discuss another important theorem which helps in evaluating definite integrals. Theorem number 2, that is integral a to b f of x dx is equal to f of b minus f of a. Notice here it is capital F. What does it represent? It represents the antiderivative of f of x. And the function f of x is continuous function in the interval a to b, while f of x, capital F of x, is the antiderivative of f of x. As you can see, this theorem makes use of the antiderivatives, which also helps in calculating the definite integral more easily and quickly, because it does not involve any limits of sum. Also, one must remember this integral, that is integral a to b f of x dx, the definite integral has to be well defined and it has to be continuous in the given interval. And what is the interval given? That is interval a to b. Alright. Now, let's solve a problem. Consider, for instance, integral 5 to 7 x square minus x dx. We have to find the value of the integral. Let's see the solution. Let I is equal to integral 5 to 7 x square minus x dx, the given interval. Now, we know by the second fundamental theorem of calculus, that is integral a to b f of x ds is equal to f of b minus f of a. That is the antiderivatives of the upper limit minus the lower limit. Now, applying this to this given integral, we get integral 5 to 7 x square minus x ds is equal to upper limit, that is f of 7, minus lower limit, antiderivative, that is f of 5. Now we have to apply the limits, upper and the lower limit, and we get it as x cube by 3 minus x square by 2 with the interval 5 to 7. Now we have to apply the upper and the lower limit, and we get 218 by 3 minus 24 by 2. And on solving, again, we get it as the final answer as 82 by 3, which is nothing but 27, 1 by 3. Thus, we have seen the main operation in evaluating the definite integral is that of finding a function whose derivative is the equation to be integrated. And this process strengthened the relationship between the integration and differentiation. Now, let's see another question. Evaluate integral 2 to 3 x by x plus 1 into x plus 2 dx. Let's see the solution. First, we have to find x by x plus 1 into x plus 2 using the partial fractions. So, if we use a partial fraction, the integration becomes much more simpler. So, we can reduce this as x by x plus 1 into x plus 2 can be written as a by x plus 1 plus b by x plus 2. Mark it as equation number 1. Now, we have to find the values of this a and b. So, for that, again, x can be written as a into x plus 2 plus b into x plus 1. Now, to find the value of b, put x is equal to minus 2. So, we get b is equal to 2. Now, for finding the value of a, put x is equal to minus 1. And we get a is equal to minus 1. So, now next step is to substitute these values of a and b in equation number 1. And we get it as like this. That is, x by x plus 1 into x plus 2 is equal to value of a, that is minus 1 by x plus 1 plus value of b is 2, 2 by x plus 2. Now, we have to take the integral on both sides. So, this will become integral 2 to 3 minus 1 by x plus 1 plus 2 by x plus 2 dx. Now, what is this? We have to use the second fundamental theorem of calculus. So, we have to find the antiderivative. So, we get the RHS as f of 3 minus f of 2. So, taking the antiderivative of x, we get f of x is equal to minus log of x plus 1 plus 2 log of x plus 2. Now, what is f of 3? We get it as minus log 4 plus 2 log 5. Now, what is the lower limit? That is 2. So, f of 2 is equal to, substituting the value, minus log 3 plus 2 log 4. Alright. Now, putting this again, RHS will become minus log 4 plus 2 log 5 minus of log 3 plus 2 log 4. And on reducing, we get it as log 25 into 3 by 4 into 16. Because it's a negative sign, it will go down. And these two are the product. So, 25 into 3 by 4 into 16. And this will be again reduced to log 75 by 64, which is the final answer. Right? Now, let's have a look at another question. Integral 0 to 1 x by x square plus 1 dx. And my question is, can you solve this particular definite integral using fundamental theorem of calculus? Stop wondering and start thinking. It will be a bit difficult to solve using the fundamental theorem of calculus. So, we should go for another approach to evaluate this kind of definite integral, and which is called definite integral by substitution. And this will be discussed in detail in the upcoming video. Now, let's have a quick recap of the entire section.
Manorama Horizon. Learning made simple.